welcome everyone to week 4. So we've got through our first 3 weeks, and this is our last week before we take a little break for our reading week. So next week we won't have any live lectures, so that's great for us all. So it'll give you a chance to catch up. So what are we looking at today? So today we're going to be, last week, start with what we looked at last week. Last week we had a look at methods, and we talked about being able to call methods and passing parameters and returning values. So we said that there was methods where they needed information, so we passed the information that it needed as parameters. There was methods that didn't need to return anything, it did all the work itself. And then there was methods that returned information, and we looked at all of those, and we had a look through some of his examples. So some of the examples that we looked at last week, we looked at drawing X's, and we looked at the eye grid and how we could write a method to draw an eye, and then being able to pass the different values meant that the location of the eye was in a different place. We put it into a for loop, we created a grid, and we had eyes all over the place. You also looked at the Celsius Fahrenheit products and cubes, so some mathematical examples as well. You quickly looked at debugging. We talked about method overloading, and we said that method overloading is when we have the same method name, but by passing it different parameters, it calls a different method. So two methods with the same name, but one of them has no parameters and one expects a parameter, and depending on whether we give it no information, or we give it information, it depends on which one it calls. And we've already used those before. We used it for fill. So fill is a method. If we pass fill one parameter, it fills the object with a grey colour. If we pass it 3 parameters for red, green and blue, it fills the shape with a colour. Okay, so we've already looked at method overloading without really realising what it was. We talked briefly about recursion. It said it was when you call the method itself inside itself over and over again. And we did tell you that we wouldn't be coming back to it, but recursion is a really important area of coding to understand and to know what it's doing. Okay, because you will, as your programming experience increases, and maybe in work situations, you may use recursion again, and you probably will use it in some of the other modules on our course. We also looked at strings, and we talked about how a string is class, and we create objects of type string, and the dot notation. So we said when we use the dot notation with a string is when we're calling the string methods. So we looked at substring for the string methods and to uppercase. So we did quite a lot last week, and over the past 3 weeks we've done a huge amount. So if you go back over the past 3 weeks, you'll have a look at the variables, creating variables, all of the different data types. We've looked at event handling. So we have looked at key press, mouse events, and again last week methods. So a lot has gone on in the past 3 weeks. So last week we also got your assignment, and before I go any further, we'll have a quick look at the assignment. I'm not going to go through it in too much detail, but what we'll do is we'll have a look at it to make sure that you've all found it, and we can come back to it. So just let me go back here for a second. So I think this is funny. I don't know anyone who's had a look today. We have a new theme. So the week of love, that's in it. This is the Valentine's theme. So yeah. So anyone who's there who's forgotten Friday is Valentine's Day. If you want my address for roses, chocolates, all of the above, that'd be great. So in here we have our assignment specification beside our beautiful love heart, and our assignment 1. Okay. So again, there's a huge amount of reading here for your assignment. So the basic, what we're asking you to do is we're asking you to create some sort of an animation. Okay. So everything that you've learned over the past 3 weeks is examinable. What we're going to do this week, you can use as well. So we're going to do arrays today. We're going to have a look at swing and some being able to have message boxes and input boxes. You can of course use those in your code, and they will be regarded as extras rather than the base of the Rubik, but I'll have a chat about that in a second. So what we've done the first 3 weeks, if you've done all of the labs, you should have enough information for what we're asking you to do. If you're unsure of anything, just pop it up on the programming channel and one of us will get back to you. So again, read through it. There's quite a lot there. We give you a little bit of advice onto how to get started and what you need to do. Somebody asked a question, during the week about the Dropbox. We haven't opened it yet, but it will be on Moodle. So read through it. There's very important here is that you're going to submit 3 files. So the commented code, a reflection and a readme. So they're important for you to really understand what it is that you've got to do here. The reflection you may think is just a document, but the reflection is your understanding of everything that you've done. And it will take you a lot of time to write the reflection. So don't think that the reflection is something that you can do quite quickly. The reflection will take a time because you'll be showing us where you've used certain things and how you've used them. Okay, and again, we will come back to this. So again, read through all this. This is your specification, talking about the text, the constraints, and what you're going to do. The constraints are very important. We don't want you going off on a tangent and doing things that are much more advanced than what we have done. We want you to see that you have learned what we've done the first 3 weeks and you're able to apply it. So to keep it to 2D primitives, so no 3D, transformations, anything like that. These are the elements that are ruled in. So, and then these are things that we don't want you to do. So we haven't done classes with you yet. I understand that some of you will have completely understand it because you've done this a bit of programming before. We don't want you to use classes and objects, except for string. No 3Ds. We haven't done array lists. We won't be doing it for another couple of weeks. So the only collections that you can use is arrays, and that's actually in as an extra. And as I said, I'll get back to that. But these are all the different things that we don't particularly want to use. Actually, I can take the J option pane off that. That should be actually up in the elements ruled in. Okay. And this is your rubric. So this is your Bible. So you'll have a look, and this is what we'll mark you out of. So you'll be looking there to make sure that you have checked all of those boxes. So use of if statements, we'll expect you to have a few different examples of if statements and nested if statements. Again, a few different examples of loops, for, while, maybe do while loops as well. Different bespoke methods. So different methods with passing parameters, returning values, maybe some overloaded methods. So a good example of each. And then processing methods, mouse methods, string methods. Okay, and there's extra credit, and the extra credit is where, it's still out of 100%. You're not going to get 110, but if you do something like, include arrays or something, we might give you some extra marks. The README, you're going to write up a README, which is the instructions for us to how to use it and any bugs. And it's very important to put in what resources you used. So we know we can have a look and see where you've used your resources. We want you to understand all the code that you write. So it's more important that you write code that's understandable by you rather than writing code that's complex and complicated and that you've got off the internet. So all the code that you write, it's better to do it yourself. We don't want to see anything that's been taken from websites or ChatGPT or anything like that. Okay. The reflection tab, again, it's when you carry out a self-assessment of your work and you'll fill all of this in. I know it looks quite small and simple, takes quite a long time to do that. So you'll be asked to have your code finished before you start it. You'll auto format your code because your line numbers have to match up. So it's important, and then your submission, and that's the date you're going to submit. Okay, and there will be programming fundamentals in the Dropbox, but it's not there yet. So again, we'll go through it again, but at this moment in time, you should be having a look at ideas, animate what you want to do, writing out the things that you think you'd like to do. So I keep saying a house. So your idea is a house. What's going to happen in that house? What are the mouse events that are going to change what's happening in the house? You know, how can you animate the house? How can you introduce all of the things that we're asking for in our rubric? So the loops, the if statements, etc., etc. So you come up with your idea, and then you think of all the things that you want your house to do, or whatever your idea is, and then you take it from there. So the design aspect for you is very important. It's the thought process of what you're going to do and what you want to achieve. Okay, so that's that. So again, we'll come back to the assignment, and we'll do it maybe in the labs or whatever. We'll have a look at your assignment. Okay. And today we're going to have a look at swing. We're going to, it's only a brief introduction into swing. So what we're looking at is we're looking at a class called J Option Pane, and we'll see what that's going to do for us. We're going to have a look at arrays. So up until now, we've been creating variables, and a variable, I keep saying, is just like a space in memory that has a name. And when you want to access it, you go to that space in memory and you get the value that's in that space in memory. Now we're going to create a space in memory that's a bit like a row of terraced houses. So if you imagine a row of terraced houses, the address of the houses is the same. So they're all Wilton Terrace or whatever it is, but each house in that row has a different number. And that's kind of like what our array is. So our variables, when we create them, they're like, you know, single houses with a family in the country, and they all have their own individual address. Whereas the array is similar to our row of terraced houses. The address is the same, but each of them has a different number on their door, and that's how we access them. Okay, so if the postman knows he has to go to number 5, he's going to go to 5 Wilton Terrace or whatever it is. So that's our arrays, and that's what we're going to do today. Okay, so let's get rid of that. Oops, wrong one. Yeah. Okay. So we're going to have a look, as I said, at swing and J Option Pane. We're going to talk a little bit about what graphical user interface is, and it's just more of a taster for you. When you move on to, and I suppose I'll say when during our lecture here today, when you move on to IntelliJ and we move on to Java in earnest, if you are creating some sort of an interface in that, you'll probably be using Java FX. But Swing is a good starting point for us, just to give us an idea of what it is that it does and how we would use it. Okay. So what is a graphical user interface? So you can see that we use them the whole time. It's what we interact with. So we press buttons on forms. We'll go to the next one. So this is probably, we press buttons on forms. We interact with the form. We have, you know, drop-down lists. We have images on the buttons. It brings us to different screens. So when we have sliders like what we can see down here. So our graphical user interface is how we normally interact. Up until now, we've been kind of using, you know, the terminal window at the bottom, and even when we start in our Java, that's what we're going to be using. We're going to be writing to our terminal. So to see a little bit of, you know, work with graphical user interface is good for us, and it just gives us a nice starting point. Okay, this is kind of what we're going to be doing today. So this is the graphical user interface that we're going to be working with. It's mostly dialog box, and a dialog box that we can maybe input information to, or shows us a message, or has a yes no on it. So that's the graphical user interface that we're going to be looking at. but that is still, it's interacting with the user in a graphical way. We're not asking the user to go to a command prompt or go to a terminal window. We're showing them a screen or a window, and they're interacting with that window. Okay, so we're going to look at Swing. So we're going to look at the class JOption pane. We're going to talk about what that is actually as a class. And then we're going to look at some of the methods that we can call upon that are in that class. So what is Swing? So Swing is a set of program components for Java programmers that allows you to create graphical user interfaces or GUI components. So I said at the start that Swing is like a tool. It's like a toolkit for us to create nice visual front ends. At the start there was AWT, then there's Swing, and now most Java programmers would use JavaFX. So we're going to be using Swing. So you can see there that these are all Swing components. So there's drop-down lists, there's checkboxes or radio buttons, whatever we want to call them, and then there's our dialog windows, and that's what we're going to be using. So buttons and sliders, and they're all different components that are in Swing, and you can play with them yourself, and I can show you out on Java Docs. If you go to the Oracle Java Docs, you'll be able to see all of the different components in Swing, and on the processing.org website there's probably tutorials, and I haven't actually looked up, but there's probably tutorials that might give you a little bit of help as well around this. Okay, so for us we're just going to be looking at the dialog and the message boxes only. Okay, so we're going to be just outputting information and maybe taking some information back in from the user. Okay. So when we want to use Swing, we're saying that we import the library. So what exactly does that mean? Java is so rich with lots of different libraries. So there's lots of lovely people out there who over the years have created libraries of code that we can use in our code to make our life easier. And one of those libraries that is being created is a Swing. And when we say a library, it's when we get classes, when they kind of package classes up together that all fit into the one kind of a mold. And in this case, they're all going to fit into a mold of helping us to create nice interfaces. So we import it because it doesn't come in as a standard. We have to tell our code, I want to use that library. And when we tell it we want to use that library, then it imports it into our code, and we can use any of the classes that are in that library. So we make Swing components available to us by importing the Swing components at the start of the program. So we can see here that we say import, oops, I'm going to put the, hopefully the sound is a little bit better now. I usually shout, so I'm probably, okay. So let me know if the sound is better. Okay. Okay. I suppose it would help if I spoke so that you can hear me. So I have the sound turned up. If that's not working, let me know. Okay. Yeah. No, I actually turned it down because I have a tendency to shout because I'm quite loud. So I turned it down today, and obviously, yeah, I have to leave it turned up. So we'll get back to this. So when we want to import Swing, we tell our code to import it. So we use at the top of our code, we'll say import, and then this here is our library that we want to import. So javax.swing. If we were to say the dot and star, what that means is include everything from this library. So the star imports all of the Swing components, and there's a lot. So we don't necessarily want to do that. We usually just import what we need. And we tell it like this is the class we want to import, and please import that for us so I can use it in my code. If we don't import it, you'll see, and I'll do an example in a second, it'll tell you I don't know what you're talking about. And plus, some of the method names, or some of the class names, sorry, are in lots of different libraries. So you have to specifically say what library you're importing. Okay, so we're saying here import javax.swing dot, and the star means everything, and you will see in a second that when we only want to import the J option pane, that's all we're going to import. We're going to just import the J option pane. So for today, that's all we're going to do. Import javax.swing.j option pane, and that will allow us to have the input box, the dialog box, and the message box. Okay. So having imported the J option pane, we can now use these methods, and we know what methods are because we learned about them last week. Methods are code that does something for us. So the show message dialog, that's going to show a dialog box that just has a message in it. And again, these are all code that some nice people or person or whatever has written for us, so we don't have to figure out, how do I write this frame? How do I put the X in the corner? How do I put the OK button onto it? Where do I put the OK button onto it? That's all been worked out for us, and we just call it and we give it the information it needs. So we're going to give it the message it needs. The show input dialog, we're going to call it, and again we'll give it the information it needs. So we'll tell it what we want to have in the input, what message we want to appear in the input in our dialog box. And then the show confirm dialog, again we'll tell it the message, and we'll tell it whether we want a yes, a no, or a maybe, or whatever else options that are available to us. Okay, so when we call these methods, we'll pass it the parameters, the information it needs to do its job for us. Okay, so a simple message would be something like this. Okay, an input dialog, it allows the user to input something, and they're going to input a string. Everything that they input is a string. Even when they want to input a number, what we have to do is we have to take that string and we have to parse it. And we'll learn about parsing it in a second. It means that I know it's a string, but I want it to be a number. Okay, and we'll do that in a sec. And the show confirm dialog. So it allows the user to choose an option, yes or no. Okay, and again, we will write the code then on the other side to deal with what they have chosen. So in this case here, in the show message dialog, it's not returning anything, it just shows a message. The input will return a string to us, and the show confirm dialog will return a value that relates to the button that has been clicked. Okay. So here's our simple message output. So in our code, we're going to write import javax.swing.j option pane, and it says welcome to the start of Swing. So you can see that that's the message that's appearing here. This null, we're going to, for this, it's like the component that it appears in. So it's like the frame, if it's in another frame. We're going to leave them as null for all of these. And our dialog box then, because it's not in something else, it's going to, I think, appear in the middle of our screen. Okay, so let's try that. Sure, we might as well try it while we're here and see what happens. And if you want, you can do it as well. So again, I'm not using setup and draw because I'm just showing you how it works. So we'll use the setup and draw when we want to introduce animation. Okay, so let's have a look at this. So we're going to say import because we want to import this library here. Okay, and don't forget our semicolon at the end. And then we're going to call that class and call the method show message dialog. So J option pane dot show okay, I'm saying null, and that means that it's not going inside another frame or inside it doesn't have a parent. Okay, and we'll just have our message then. So I'm just going to bring that onto the next line, and we're going to say welcome okay, and if I run that, okay, hold on for a sec. Apologies for this. I obviously have a spelling mistake here somewhere. See, these are the kind of things that you shouldn't be doing. Oh, it's because, yeah, so it's not a shoe, it's a show. Sorry. Okay, and we can see in the center it says welcome to week 4, and it's just a little message. So again, you can see that I got a mistake because I had a spelling mistake there. So again, it says welcome to week 4, and as I said, because it's not in a parent component, it should be in the middle. It actually, I have 2 screens, so it went into the middle of the other screen. So let's have a look at this again. Okay, it's weird. I can't see the I there, but there is an I there. Okay, there we go. So you can see if I take out that import statement, I get an error here. It says the name J option pane cannot be recognized. And that's because it doesn't know where you want to take it from. So you've got to tell it, I want to import it from this library, and this here is the class I want. And again, if I say star there, it's going to import everything, and you can see it still works. Okay. So let's keep going. So you can try that yourselves as we go along. Okay. So you can see we had our import statement and we had our let's learn about swing. So our text that's going to appear in the dialog box is what appears here. And our null, as I said, that's for our parent container. And we're going to keep them all null for this. They're just going to exist by themselves. Okay. So what's this? So if we want to have a label on it, so you can see that this one here, it just had a message and it says here message. So if we want to be a little bit more nicer about what it is that we're doing, we want to give a label to our dialog box. Then we will say this. So again, our show message dialog is the name of the method. And as we learned last week, we talked about overloading. So now if I pass it, if we go back here, you can see show message dialog. We passed it 2 parameters and it produced this. When we pass it 1, 2, 3, 4 parameters, it produces it like this. So it's null because it's existing by itself. Welcome to the first day of spring. That's the message we want to appear. The title is the 3rd parameter. So that's the 3rd parameter. And then the 4th parameter that we're passing it is we're saying jOptionPane.plain message. And that's getting rid of any of the icons that are out down there. So again, there's different parameters, values for this parameter that we can pass. And I'll show you those again. We go to Java and we'll have a look at those as well. So if we want to have it with a message and a title, well then we pass it 4 parameters. Okay. So you can see here that this means no icon. Okay. Our 3rd parameter is our title. Now here's where we're starting to get into more helpful for us. So if we want to be able to take information from the user, at the moment when we're writing our code so far, we haven't been able to pass in information. So all of the things that we have done has been, we've kind of hard-coded values, or we've used the location of our mouse X or our mouse Y. Now we can pass it in information. And when we want to pass it in information, we can use this method called showInputDialog. So again, the class is jOptionPane. We're calling the method showInputDialog. You can see in this one here, if we pass it 3 parameters, we're going to pass it the parameter for our message, the parameter for the label that's going on our question, and then a suggested answer. So that's our default is going to go in here. ShowInputDialog is a method that returns something. So it's going to return a string. So we're going to store what it returns in a variable. And in this case, we're calling that variable day. So let's have a look, because there's quite a lot going on there. jOptionPane is the class. ShowInputDialog is the method. We're passing it 3 parameters. Our message, the label for our text input, and then a default for our text input. Okay, and you can see that then, whatever the user enters there, it's going to store it in here in day. And then we can use it later on in our code. So in our next set of slides in arrays, we're going to read in numbers and we're going to store them in our arrays. So we're going to have a loop that's going to read in our numbers, which is brilliant, except for the slight problem is that our showInputDialog, it returns a string. It doesn't care what you put in, it just says that's a string. So if you type in 22, it stores it as a string 22. And it can't be used as a number unless we do something special with it. And what we're going to do, the special thing we're going to do with it is we're going to tell it, look, I know you think you're a string, but actually you're a number. We're going to parse it. Okay, so we're going to use a predefined method to convert it to a number. Now we have to be careful that we're always converting a number to a number, and we don't want to crash our program. But today we're always going to do exactly what we're supposed to be doing. Okay, if we enter in 22, we're going to convert it. Okay, so you can see here what we're doing. We're using this integer class. So again, we're starting to see these capital letters. These are the names of classes. after our reading week, we're going to go through classes in more detail. But just for now, I want you to know that this integer class is a class that has been written, that has methods in it that help us. One of the methods takes a string and converts it to an int. So we call the integer class, we call the method .parseInt, and we pass it the string that we want to be converted. And after that, once it's converted to a number, we can use it as a string. Okay, so it's going to take this 22. So it's going to take our 22 here. Okay, and sorry. And it's going to convert it to 22 that's going to be stored in a variable called number. Okay, so you can see we know it's a string because it has our curly, or has our inverted commas. So we're taking a string and we're converting it to a number, to an int, and that's what we're storing it as. So integer is the name of the class, and we're calling the method parseInt. ParseInt expects a string, we're passing it a string, and it returns an int. So using parseInt with input. So look what's happening here. So we're saying we're calling our J option pane, we're calling the show input dialog, we're asking it to enter a number. That's our message. This is our default of being 3. This is going to return a string. We're going to take that string and we're going to parse it to an int. So again, a lot going on there. Okay, so this converts the string to an integer and stores it in num. Okay, so I think we'll go back just to this one for a second. And I'll embarrass myself with my typing skills again. So this one here, our integer.parseInt, I could do it on 2 lines if I wanted to. So I could say this. Okay. Sorry, let's do camel case. So that should be num string like that. And So now what I can say is, instead of having it all in one line, if you understand it better, you can do it in 2 lines. So remember, show input dialog, it returns a string. So we can store that string in a variable called numString, and then we can take that variable and we can parse it to an int and store it in num. Those 2 lines of code are exactly what's going on there, except it may look slightly more confusing there because it's all in one. But what we're doing here is we're taking in our number, we're storing it as a string, and then we're getting that string and we're telling that string you're an int. Okay, so let's have a work this. So enter a num, so you can see it enters the num. 3 is the default. I'll change that to 56. Okay, and you can see it adds 5 to 56. So it converts it to an int and it uses it and adds 5 to it. Okay, so again, if we're looking at that 1 line of code, these 2 lines of code are exactly the same, does exactly the same thing. So you're going to use whichever one makes more sense to you. This is doing everything in 1 line. This is doing it bit by bit. So we talk constantly about knowing the steps that we have to take and being able to work out the steps. So this here is 2 steps, and it just is put into 1 here. Okay. So our show confirm dialog. So were you working on the February bank holiday, yes or no? So again, this is our show confirm dialog. So that's the name of the method that we're calling. We're passing it null, we're passing it the message, and then this is our question that appears up here. Okay, and then this J option pane yes no, that's telling us what buttons are going to appear here. Okay. Okay, so J option pane. So you can see here when we call it, it's going to show the dialog, and then depending on what the user enters, it's going to return a value. If the user enters yes, it'll return J option pane yes underscore option. And if it returns no, it'll return J option pane no underscore option. Okay, so we'll have a look at an example in a second. Okay, so here's our code. So we'll have a look at our code and we'll see what's happening. So we're importing it. We're telling our code, I want to have our J option pane. We're calling the method show confirm dialog. We're telling it it has no parent component. We're asking it, this is the label that's going to appear above the yes no. This is our message header, so our bank holiday question. And then these are the buttons that are going to appear. So it's going to look like this here. Were you working on February bank holiday? Yes, no. So that's the code. And then if the user presses yes, a value is going to be returned and stored in reply. Now, you may notice that it says int reply, but yet I'm telling you that this is what's going to be returned. Yes underscore option or no underscore option is what's going to be returned. What they are what we call constants. And in the background, in J option pane, it has a constant, it's a variable called yes option, and it has a value of 1 for yes, and the no option has a value of 0. So actually what's stored here is a 1 or a 0. Okay, but they just, in our J option pane class, these variables have been defined as constants. We know they're constants because they have uppercase. So anything that's a constant and a final variable, we will create them as uppercase. So these are values that don't change. So what we're saying here is when we press the yes, a value is going to be stored, a number is going to be stored in reply, and that will be either a 1 or a 0, which relates to what this yes and no are. Okay. So here I'm saying if whatever is stored here is equal, so is equal to, so remember 2 equals, and that tests for equality, the yes option, then we say that's no fun. Else we're going to say hope you enjoyed your day off, and we'll change the background color. So okay, so I'm going to go back to this piece of code in a second. I'm going to let you do it and we're going to take a little break. So just what we did in J option, in summary, we looked at swing, we looked at our J option pane, we said we had to import it, we had a look at these methods here, we talked about parseInt, and then we said that parseInt takes a string and parses it as an int if it is an int. Okay, so be very careful. We talked about our dialogues, and we had the yes and the no. So remember we were saying that these are actually integer values that are being returned, and J option pane has them stored as constants. Okay, before we go back to the code, I just want to show you here. So if you go into your Oracle and go into classes for J option pane, you can see here the different methods and a description. You can go down, it tells you what the different messages are that you can put. So I think we had or we had plain message. So where we had plain message, you can have a question, a warning, an information message. For our default for our option, we had yes, no option. You can have yes, no, cancel, okay, cancel, and so forth. So you can go and have a look at this. It's not always the same because processing is slightly different, but you can have a look at it and see, and you'll get some ideas. So we just go back to your code. I'm going to give you, we'll come back at 10 past, so that's 8 minutes. And hopefully in that time you will have a go at that and see, can you get it? And if you have any questions, just give us a shout. Okay. And we come back at about 10 past. Sorry, I'm just laughing. That was the first time I used my timer, and I normally don't let it finish up, but I let it finish up, and it gives this big bong. So I must let you hear it. It's quite funny. So hopefully you had a chance to do some of the code. Again, in your labs, you'll be doing. There's some of the labs are around the J option pane, and our arrays that we're going to be going on to now, we're going to be using J option pane again. There are other ways if you don't want to use J option pane. If you want to include it in your get numbers in your code, you can use key press strokes. So up until now, you've been using like key events. So you can actually record what you're pressing, and you could use those key events to create a number or to create a string. But it's a whole lot easier if you use the J option pane. But it's completely up to yourself. It's whatever way you want to learn or whatever you want to learn yourself, as long as you're keeping with the principles and you're keeping with what we're explaining to you and telling you. And you can go into your tangents and learn what it is you want to learn. But just keep coming back to your if statements, your loops, your methods, and ensuring that you understand where you are and what they do and what the parameters are. And again, even in that J option pane slide deck that we just did, there's a huge amount in parameters, the different parameters, the method overloading. Why did we have 2 parameters that time and we had 4 the next time for the same method? So how do you know that? How do you know that you changed the parameters? And the only way you know is practice, looking at it, going to Java docs and on the Oracle docs and having a look up and seeing what the parameters are, and playing with them. And when I say play and figure it out, it's great to do that, but you have to understand. And if you don't understand, just ask us and we'll help you with your understanding, and then you comment it. So once you learn something, you should then comment it so that the next day when you come back to it, you'll completely understand what it is because you learned about it the previous day. And as I keep saying, don't assume that the next day you come, you'll remember it. You must comment it. And even in a work situation, when you're in a work situation, we comment our code in a work situation, because when we come back a year later, 2 years later, that fancy piece of code that we thought was brilliant, hadn't a clue what works. You have to practically start again and try and follow it the whole way through. So it's good to get into the habit of commenting your code, and the comments that you use now will be long-winded. And as you get better, you'll comment less, but they'll probably be a little bit cleverer in the way that you comment. Okay, so we'll continue on anyway. So hopefully you had a chance to look at the code. I meant to write it in while we're on the break and I got sidetracked, sorry. But you can write it in your lab and have a look and play with it. Play with the different options. Have different, maybe the cancel button. What would you do if it was the cancel button? Would you want a dialog box to appear to say, oh, you've cancelled me, or whatever it is? So play with the different options and see what's happening. Okay. So, and if you've any questions on this, Mairead is online, so she can give you a hand. If it didn't work for you, just pop it up and we'll have a look at it. Okay, so we're going to start with arrays, and at the start I talked about the houses in the countryside and your terraced houses, and really that's how I learn. I visualize things. Everybody learns differently, so if whatever way you want to visualize what an array is, that's completely up to yourself. But I like to think of it as being the row of houses, and each house has a number on it, and that's how we access it. Okay, if we want to go to, we live across the road, we work across from Ballybeg Drive. Ballybeg Drive has terraced houses, so if we wanted to go to 5 Ballybeg Drive, we'd walk to Ballybeg Drive and then we'd find number 5 and we'd knock on the door. So that's exactly what we're going to do with arrays. We're going to learn how we do that in code, and what's the notation for that. So we're going to look at why arrays, our primitive arrays that we're looking at, and the array syntax. So why arrays? So we're going to look at bits of code that's going to help you with that. I'll just get rid of my head there. Okay. So we're going to look at different bits of code to explain the concept. And in each piece of code, we're going to read in 10 numbers from the keyboard. We're going to add the numbers, and we're going to print the sum of all the numbers. So we're going to have pieces of code where we read them in and we lose the information. We're going to have pieces of code where we read them in and we store them in 10 different variables. And we're going to have a piece of code that's nice and neat and that we can introduce loops to, where we have an array. Okay. So if we want to add in 10 numbers, okay, we have our option pane, which we're importing, and then we're creating a variable called n. So let me have a look and see. So when we run this, we're going to, in memory, we're going to create a variable called n, and we're going to create a variable called sum. Into sum, we're going to put 0, and actually n will automatically have 0 because that's the default value for an int. We have our for loop. So inside here, we're going to create a variable for I, and I is going to have 0 at the start as well. So let's have a look at what our for loop. Remember, our for loop has 3 components. It has our initialization, it has our test, and it has our change. In this case, we're incrementing by 1 each time. So inside our loop, we're calling the J option pane. We're calling the input dialog. We're asking it to enter a number. And we're going to take whatever it enters. We're going to call our parse int, and we're going to store it in n. So there's a lot going on there again. So when our option pane, our dialog appears, we're going to enter the number. Whatever we're going to store it into n. So let's say the first time we enter it, we enter 4. So we'll put in 4. Okay. Sum is equal to, so look what's happening here. Sum plus equals. So that's the same as saying sum equals sum plus n. Okay, so that's the same as this. So this plus equals is the same as saying equals sum plus n. So we're saying into sum, put the value that's currently in sum, which is 0, plus n. So into n, into sum, we're going to put 4. Then we come back up here. So at this point here, we increment I by 1. So I is now 1. Is 1 less than 10? Yes, it is. So it goes in and it does this again. So let's say this time we enter in 6. So now n will be overwritten with 6. Sum is equal to plus equals n. So sum equals what's currently in sum, which is 4, plus what's in n, that's 6. So 4 plus 6 is 10. gets to here, it increments I by 1. So now I is 2. Is 2 less than 10? Yes, it is. And it comes in and it does it again. So you can see here what's happening here. When we get to this line here, so I will have become 10. And then it'll come and it'll print the sum of the values you typed in is whatever value at that moment in time is in sum. Okay. So when we want to add 10 numbers, in this case here, we're reading them in and we are just storing the number that we have input at that moment in time. So the history of the numbers that we've taken in, we've lost. Okay. So each time a number, it overwrites the value stored in N. It doesn't remember the individual numbers typed in. So that might be what you want, but in a lot of cases it isn't. We want to keep a history of the information that's been input. So we're going to introduce this rule, and our rule is never lose input data. So we always try to store the input data for later use. In real life systems, we nearly always use it again. So think about that. So if, let's say for example, and we're going to get to student marks, if we were inputting student marks, we'd want to keep track of the marks that were input. We wouldn't want to lose them. If we were inputting dates of birth, we'd want to keep the dates of birth. We wouldn't want to lose them. So we wouldn't want to overwrite or ages or whatever it is. So we want to keep the information. So how would we do that? Okay, well, one way to do it is just to create variables for all of the pieces of information that we want to keep. So if it was 10 numbers, we'd create 10 different variables in memory, and we would keep those variables in memory and then add some at the end, and hey presto, we have remembered the numbers. And that's grand and that works, but does it scale? With 10 numbers, yeah, fine, that's 10 different variables. But if we had 100 numbers, what would happen? Okay, so, and again, if we had 10 to start off with, and then next week we had 20, well, now we have to make 10 more variables. And imagine if we had 1,000 numbers, we'd have to have 1,000 variables, each with their own name, in each having to be, each piece of code here has to be written over and over again. So again, like our postman has to go to all the individual houses in the countryside, okay, it doesn't, you know, it's not great when we have lots of numbers. And we've said all along, coding is great, programs are great for calculations. So they can calculate really, really quickly, but not if the information is all over the place. And we have to write code to deal with it all the time. And we can't create variables on the fly. So anytime the numbers change, the code has to change. So that's not, it's not maintainable. So we need a new approach, and that's why we're looking at arrays. So arrays are a way to collect associated values. So in the heading it said arrays fixed size collections. So what that means is at the start when we create the array, we create it to be a specific size. And then we're able to put the information in. Bit like when the row of houses are built, there's a number of houses built at the one time. Okay, and that's our terrace. So they're a fixed size. Programming languages usually offer a special fixed size collection. In Java, it's an array. And a lot of programming languages, they're called arrays. But we also have other types of collections, and we will be doing those over time. So after we move to IntelliJ, we'll be looking at different types of collections. Okay, but the fixed one that we're going to use is called an array. So Java arrays can store objects, primitive type values. So what's an object? So we haven't done writing our own classes yet, but we have been using objects. So we have used strings. So strings are objects. So Java arrays can store strings. They can store primitive type values. So it can be an array of integers, array of ints, an array of doubles, an array of chars. So array of booleans, true, falses. Okay, so that's our array can store any primitive data type, and it's going to be able to store objects when we get to objects. But they all must be the same. So array can only store one type. So if we create an array and we say it's going to store ints, that's what we must put into it. And arrays use a special syntax. Okay. So when we create a variable, we say int num equals 17. And I keep typing that out, and drawing it out, and I say, this is the memory. In memory, we create a space in memory. We call it num. We say it's going to store an int, and we put the value 17 into it. So that's what that piece of code there is doing. It's creating that. And then if we want to use it, we use num, and we use the value that's stored in num. Oh, great. Just won't delete this for me now. What will I see? Can I? Okay. Don't know how I managed that. Okay. I'm just going to close off the script for a second. I just want to see, can I get rid of all that writing, and I'll be straight back to you. Sorry about this. Okay, we're back. Sorry about that. I added annotations rather than actually drawing with my pen, so apologies for that. So we said we created our space in memory, and we created a variable called num. We put the value in. So we're going to look at structure that can store many values of the same type. So imagine a structure made up of subdivisions or sections. And such a structure is called an array, and it would look like this. Okay, so here we have our array. We have each element has an index, and we put a value into it. So in this case here, we have 10 elements. You'll notice the first index is 0. So in arrays, our index always starts at 0. So that's the equivalent of if we had a row of houses, look, I never said I was going to be an artist, so, and these are our houses, and our houses start at 0, 1, 2, 3. So it's the same idea. Our array always starts at 0. So when we create our array in memory, so remember how we created our variable. We said data type, variable name. When we create an array, we say data type, square brackets. Oh, I'm not doing it again. Sorry. Square brackets. Okay. So square brackets and then the name of the array. And what that does is it creates a space in memory. And we're telling it, I'm going to have an array here. We haven't actually created the array yet. We're just creating a space in memory that's going to point to our array, that's going to have the address of our array in it. Now when we say our array is equal to new, our new is going to become very important to us as time goes on. So when we start creating our own classes, we'll start to see the keyword new. And this is our construct. This is when we construct our array. So what we're saying here is, here we're saying create, we're going to have an array called numbers and it's going to store int. Here we're saying create that in memory. So construct it and it's going to store 4 integers. So it's our array, which is numbers, is going to point to 4 integers, 0, 1, 2, and 3. So these are the numbers that are on our doors. So this is our index, and this is the values that are going to be stored in it. And you can see here that they default to 0 because integers default to 0. Okay, you can decide how you want to write it. I have a tendency to write arrays like this. And I give it a name, numbers. So that's just the way that I visualize it. I visualize it, the index on the bottom and the values here and the name above it. You know, others visualize it like this. So again, it's whatever way you visualize it, but whatever it is, you're creating a space in memory that's broken up into this number of values. So 0, 1, 2, 3. So that's 1, 2, 3, 4. So it can have 4 spaces in it. Each element is going to be an int and it's called numbers. Okay. So we've declared an array of int with a capacity of 4. Each element is of type int and the array is called numbers. Okay. You will see these square brackets behind the int or behind the numbers. I think behind the int is the correct way to do it, but it can be either behind the int or the numbers. So we'd say we're creating an array of int called numbers, or it could be we're creating an array called numbers of type int. And we'll see both ways as we go through it. Okay, so that's the index. And this is the value. If we want to access an element, it's the name of the array followed by our square brackets, and this will have the element number in it, and this will have the value we're putting in. So you can see into our numbers array at element 2, we're putting the value 18. So we're putting the value 18 into there. Into our array called numbers, at the index 0, we're putting the value 12. So we're setting the element at index 0 to the value of 12. Okay. So in this case here, we're printing. So if we want to use the value that's stored, we just use the array name and the index that we're looking for. Okay, so in this case, we want to print the value that's stored in our array called numbers at element 2, and that's going to print 18 to our console. Okay, So declaring a primitive array, int numbers equals new int. Okay, so we can do it in 2 steps. Or we can do it in 1 step. So we can create it. So this is where we declare it and we initialize it. So we're telling our code we're going to have an array called numbers. It's going to store, it's an array of int, and it's going to have 4 elements. So that's the same. So again, this here, the first way is 2 steps, and this is 1. Okay, so sometimes we do it like this. So we might declare it globally to say that we're going to have an array, and then inside our setup or inside our draw, we might ask the user, how big do you want your array to be? And then we create it to be that size. We construct it to be that size. Okay, so let's go back to our example that we were working on. So we're going to read in and sum the 10 and convert it using primitive arrays. Okay, so in this case, it doesn't save it. So we've said that it overwrites it every time. So let's have a look at what we're doing now. So this time we're creating an array. So in memory, we're going to create an array. It's going to store 10 elements. It starts at index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now they'll default to 0. I'm not going to put it in to make my life a little bit easier. We're creating a variable called sum. And then we're having a loop. So you can see here now we can loop through it. And we're saying I is equal to 0. So that means in our array, at element I, place whatever we enter here. So I is 0, so therefore we're going to put the first number in here, 6. It'll go back through, I will be incremented by 1, so I will be 1. So the next time it'll say in my array numbers at element 1 plus the next value, whatever it is. Then we'll go back up. I will be now 2. In my array numbers at element 2, put in our value, and so forth. So now we can very simply change this and make it bigger. So we could make that 1,000, we could make that 1,000, we could make this 1,000. And all of a sudden we only have to change code in 3 places, and we can have read in 1,000 numbers or 10,000 or 1,000,000 or whatever numbers it is we want to read in. So we don't have to create 10,000 variables. We don't have to lose data. We can input our data and use our array. Okay. So we create our array. We say it's going to store 10. We read it into element I. So again, it's a good exercise to do this, maybe not with 10, maybe with 3. And just to write what's happening each time. So you can see how your for loop goes through your array element by element and enters the data in element by element. Be very careful that you use the less than whatever the size is, not less than or equal to. And always make sure you start at 0, because that's where our array starts. It starts at 0. And our I was always going to be, our LCV or our counter value is always going to be 1 less than the length of it. Why? Because it starts at 0. So if we have space for 10, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are little things that kind of catch us out sometimes because we forget. If you put in the wrong value, it won't catch it when you run it. It won't catch it when you compile it until you run it, and then it'll crash because you'll be trying to access an element that doesn't exist. So like your postman if you send him to the wrong number. If he's gone to Ballybeg Drive and there's only 14 houses in Ballybeg Drive and you send him to house 20, doesn't exist. So he doesn't know what to do with the letter. In coding, in our program, it'll crash. So we've got to be careful. So when we sum it, again, we're looping through it and then we're adding whatever is in our numbers to our sum and then we're printing it out. So can we reduce the code to only have one loop? So can we put the reading and the summing of the data into one? Yes, we can. So in here, after we read it in, we can straight away add it. And then we can print it out. So move the sum code into the first loop, and then we don't need to have two loops. And then if we wanted to, we could find the average once we have the sum. Okay. What if we wanted the user to decide how many numbers they wanted to sum? Okay. So again, we can ask the user to enter it in. So we're using our J option pane. They're going to enter in a value. Remember, with our J option pane, it returns a string. We're taking that string and we're parsing it to an int. And then we're storing that int in num data. So now the two steps make sense. We're creating our array. So we're declaring that we're going to have an array called numbers. And again, remember I said before, you can have the square brackets after int or after numbers. Okay, both do the same job. We're asking the user for a value. They're going to give us a value. So now we can say we want it to be 10,000 or we want it to be 5. And our code isn't going to change at all because we are dynamically allocating the size. So here we're saying our array numbers make it to have whatever we've entered in size. So new, int, our square brackets, and that's going to be our size. We're going to go read through it like we've learned to do already. The only thing that's changing here is we're using this value that we've taken in from the user. So if they have entered 10, it'll be I less than the value that's stored in num data, which is 10. Okay. So we declare numbers to be an array of type int. Num data takes in the size, and we use num data to initialize the array with the new specifying the size. So we're not hard coding the size of the array. It depends on each time we run our code. It can be a different size. So an array can store any type of data. We've been using primitives, so it can be an int, a byte, a char. And again, it's your data type and your variable and your array name. And then your square brackets can be here or here. Byte, give it a name. Char, give it a name. And then you'll tell it how big you want it to be. So this is when you construct it. You call your new keyword. You say it's going to be int again and how big it's going to be. Okay, the only objects that we've looked at so far have been string. So here we're creating an array called words. Oops. And it's going to, so that there's actually missing your square brackets there. Sorry. Sorry, they should be square brackets. That doesn't look very square there, does it? Can I make it a little bit thinner, I wonder? I'll fix those in our notes. They should be square brackets. So we're creating an array called words, and each element is a string, and it's going to store 30 elements. Do we have to use all the elements in the array? No, but it could cause logic errors if we don't take into consideration in our coding. So when we're looping through it, at the moment, all of our loops went to the end. But you can imagine that if I have 30 people in a class, or sorry, 15 students, and they have a test, there's always going to be someone who's sick on the day, or can't make it in, or missed the bus, or slept it out, or whatever the story is. So we may not have all of the students. So the array may be 15, because it's going to store 15 students, but we may not have all of the students in doing the exam on that day. So we will have our result, and you can see here we have the first 12 elements are filled. So therefore 12 students arrived on the day and 3 didn't. So we'd want to keep that remember that when we're doing it. So we'd create an array with a capacity of 15. Only 12 students sat the exam. So we only record the first 12. And to calculate the average student, we divide by the number of populated elements, not the array capacity. Okay. So we might want to keep another variable, and that variable will tell us how many elements have a value in them. Okay. And in this case, that might be size. So we might go through the loop the first time and take the values in, and then stop it when there's only 12 or whatever it is, and then that's what we use from there on in. Okay. So for now though, we assume that all elements of the array are populated and therefore ready to be processed. So while we're just learning, we're not going to worry too much about that, but we will come back to it, and in some of our labs we will look at being able to know whether we're using the full array or whether we're only using the parts that are populated. Okay. So in summary, arrays are structures that can store many values of the same type. We don't want to lose data, so arrays enable us to store the data efficiently. We can use loops with arrays, and arrays can store any type. So we can either do it in 2 int square brackets the array name, and then the array name is equal to new int. So that's when we make it a certain size, or we can do it all in one. Okay, and questions. Let's go back here for a sec. Okay, so again, a lot of code here. I would suggest that you try and do this yourself. Understand what's happening here, that we're asking the user. So when we write the code, we don't know how big it's going to be. So we don't know how many elements is going to be in our array. So when we write the code, we don't know. So we write it from a dynamic point of view so that the user can tell us how big it's going to be. Because remember what we said about arrays, we said they were fixed length. So we create them to be a certain size, and that's how big they are. Okay, making an array bigger can be done, but there's a bit of overhead involved with it, and we won't be doing it. We'll be moving on before we have to do that. So in this case here, just be sure you understand that we're creating an array. So what's happening here? We're So this line here, it would help if I didn't write in black. We're creating a space in memory that's called numbers, and it's going to point to something. Here we have an array called numData. That's going to be populated by our option pane. So if we say 5, so the person said I'm going to have 5 values. Then on this line here, so this line creates this. Then on this line here, we're going to create our array using numData. NumData is 5, so that's going to create 5 elements. 0, 1, 2, 3, 4. And that's going to point to that. Okay, and because it's an int, they will all default to 0. Okay, and then the next time it runs, num data could be 6 or 7 or 1,000 or 10,000, depending on what the user enters here. So again, I want you to have a look at that, have a look at JOptionPane, go back and have a look at our Java, oops, where are we? Our docs, our Oracle docs, and you'll find, as I said, more information there about JOptionPane. So there's lots of good information there, and we'll quickly just do our last one. I promise you it's only the summary, so we're just finished. Okay. Oops, that should say summary. Sorry. So today we did our introduction to Swing, and we looked at arrays. And if you can remember that an array stores multiple pieces of information of the same type, and each element is stored at an index which can be accessed, and we use square brackets with arrays, and our array starts at index 0 and always goes to 1 less, and we usually be able to navigate through them using loops. So we can use a for loop, which is what is in our examples today, or you could use a while loop or a do while loop, whatever it is you feel most comfortable with. Okay, so again, we're finished on Wednesday. We'll be looking at more array examples, and we'll be looking at file handling, so which is great because it'll show you how we read information in from files and how we write information out to files. And Prosing is quite good at doing that, so it's a nice simple introduction. And then again, when we moved on to Java, we'll be using it again. So hopefully tonight you'll be doing your labs. Pete will be on later on, so that you can have a chat with him. If you have any questions, just give Pete a call. If you have any questions about anything that we've done today, just come along to your lab and ask Pete. Slack, we get back the whole time, but as I said, the people in your class have been brilliant. I have noticed that a lot of the answers that are coming in on Slack have been to the point and very concise and clever. So I'd like to thank all the students who are helping, and I'd like to thank all the students who get in there faster than I do, because it really makes a difference to people who are asking questions, because they can move on. Because there's nothing as frustrating as when you're trying to code and you come across something and you can't do it and you can't see the problem. And I would say to you, if you can't see the problem, just walk away and come back to it. And when you come back with fresh eyes, you will see, maybe like today at the start, I said show with a W, I said shoe, sorry, SHOE rather than show. And because I was in panic mode because I'm in front of you, I was like, oh no, I can't find it. But once you kind of just take a step back, it just pops out the whole time. So, walk away, come back, show someone else your code, or even talk to somebody at home. Tell them, explain your code to them. And in your explanation of your code, sometimes you actually see where you've gone wrong. So the person you're explaining it to doesn't have to understand it. But you have to try and explain it to them. And as you step through it yourself, you go, you know what I did wrong there? That should have been an int, or I forgot to parse it, or I did this, or, it's a string, of course, I can use substring there, I can check to make it uppercase. You'll come across lots of little things yourself as you explain it to somebody else. So have fun. We'll talk to you again on Wednesday, and your labs are tonight and on Wednesday. Okay, see you now. Bye-bye.